Show time Fourier analysis. Again, this is not part of the windowing function. Okay, this rectangular window. Okay, again, you see this is the we call the first peak. Okay, the main peak, the first peak. The difference between the two, we call this first side lobe loss. The places where this the first node occurs is where this node occurs multiplied by two. That's the called the main node width. Okay. This is a windowing function, okay, rectangular with 64 points. Handing window, okay, again, looks something like this. Okay, it goes to zero, it goes to zero here. You see the frequency responses. The first thing you see that the main node width gets wider. Okay, so the frequency resolution gets worse. The drop in the side node thing you see it's much better, right? This is almost 30 dB, right? This is almost 0 dB, so you have almost 30 something dB loss of your first side lobe. Okay, Hamming window. Okay, look at this plot. In this plot, the only thing that sort of changes, okay, is the Hamming window decays almost close to zero at the boundary. Okay. Hamming window, it decays not quite to the zero, then to the zero. Okay, it's sort of a combination of a good thing between the two. Okay, so in the rectangular window, there's no decay. Everything is one within that window. So you look at frequency response of the Hamming window. Okay, again, 7% length, 64 points. This is the width. Okay, again, compared to rectangular window, it's much wider, okay, which has a bad resolution for frequency. But the rest of the side lobe leaks, they're very constant and they're very low. Okay, so again, you have an equal contribution of every other part of the signal of the frequency into the original signal, but they're at a quite a low location, right? It's about 30 dB, it's about -10. So you have almost -40 dB loss across all other auxiliary frequency component. Okay, that's Hamming window. Okay, change that Hamming window to a longer length. Okay, the only thing, this loss, right? The side lobe leak losses doesn't change. It's about still -40 dB loss. But you see is the main lobe width gets shrink. Okay, so by changing the number of points, this side lobe leak, the main lobe width gets shrink and shrink. All right. Okay. What's this? Okay. So this is rectangular window. Yeah, rectangular window. Okay. This is the original signal, some sign of oscillation. And if you plot them, okay, you'll see. Okay, there's a peak here at 5 Hz, but you still see this auxiliary peaks here. Okay. So I mean, original signal, there's nothing else except for 5 Hz. Now you apply a windowing function. Okay, of certain length, okay, certain length, a rectangular function, and then plot this finite length signal into a short time dependent Fourier transform. And look at this thing, okay, you see this is the peak, that's right, but you still have all these peaks that's, they shouldn't be there. Okay, these are just mainly because of the rectangular window has those side lobes. So, and you have a peak here, the rest of peak here. All right, and what's this? Okay, this is fundamental frequency 20 Hertz. Okay, again, the sine wave rectangular window. Again, similarly, you see it's 20. Okay, here. Let's change that to Hamming window. Okay, Hamming window again, frequency 20 Hertz. Instead of using rectangular window, we use a Hamming window. Look, compare this one to the rectangular one, right? So you can clearly see the difference, right? So Hamming window, it really sort of shrinks or keeps all the other thing at a very low minimum level. So you want to know, okay, there's a peak here compared to other peaks you see in a plot. It's very easy to know there's a peak because the rest of them are so low. Okay, but the problem is this width is wide. Okay, the width is wide. So here, the width is much smaller. Okay, so you can imagine if you have a signal. Okay, this is somewhere between, right, 28 or 18 to maybe 22 or so. If you have another signal that also oscillates at say 22 Hertz, okay, then this main lobe width will not be able to differentiate between the two peaks. You don't have two frequency within this thing because they will always be processed within this main you just get a lobe that's even wider, okay, but still single peak. That's a problem with the Hamming window. If you do a rectangular window, right, if you have one that's 20 hertz, and have another one that's 21.5 or 22 hertz, right, look at here, you'll see another little, you'll clearly see another little peak here, okay, which will tell you there are two frequencies in your